The following is the video solution from JSDT Solutions. Question 3 says, it is given that the general term of a quadratic pattern is Tn is equal to, and we have this. Okay, notice some things are filled in, only B is missing. And the first term of the first differences is 7. Okay, so we need to show that B is equal to 4. So the first term of the first differences, think about where that is. Right now, all they gave us is the value of A. We can see that A is equal to 1, and we know the value of C. C is 9. And the first term of the first differences is 7. Remember how your terms go like this. You have the quadratic pattern, and then when you subtract their differences, it gives you the first differences. Now what they're telling us is that this first term is equal to 7. Think about what we equate that to, because that actually includes A and B. We equate this one, the second difference, to 2A, and then this one we equate it to 3A plus B. And so that's the equation we're going to use. 3A plus B is equal to 7. Okay, so in order to solve for B, we need to know what A is. But we actually do from the general term. We know what that is. So that's going to be 3 times 1 plus B is equal to 7. Okay, so this is B equals 7 minus 3 when we transpose it. Therefore, B is really equal to 4. And that is our answer. Question 3.2 says, determine the value of the 60th term of this pattern. Now we have the complete pattern. We can say Tn is equal to n squared, and now we know what B is, so plus 4n, and that was still plus 9. And we just have to find term 60. So say T is 60, and in place of n, substitute 60. So 60 squared plus 4 times 60 and plus 9. Therefore, term 60 is equal to 3849, and that is our answer. Okay, moving on to the next question. Question 3.3 says, determine the general term of the sequence of first differences. So we're trying to find the general term of the sequence of the first differences, really, of this quadratic number pattern. Okay, so the first difference is general term. Write your answer in the form of TP equals MP plus Q. With this question, we can use a grade 10 approach and it's going to work out fine. So just using what we know about this is TP, it's in the form of TP is equal to MP plus Q. You see the M stands for your constant difference, your difference, okay, because it's an arithmetic sequence. This is the general term of an arithmetic sequence. So that is that constant difference, which we know as 2A. Okay, now we already know what A is in our pattern. A, the value of an squared plus bn plus c, A is 1. Okay, so we'll say 2 times 1, and that's what's going to give us the difference. And this would have been written as dn plus c. But let's just not write that c because it's going to confuse with this c. There are two different c's. Okay, this is c in the arithmetic, that's c in the quadratic. Okay, so this means that we have the second constant difference being 2. And that's what we're going to use as our dn. Okay, so m is equal to 2. We know what that is now. And then now that we know this, to update this is TP is equal to, and we'll say that is 2P plus Q. And now Q is what is missing, okay? Because this is really like Tn equals 2D plus Q. Okay, let's not call it C. So this is what we have now. How do we find Q? This is just an equation. If you know one of the term values in this pattern, you can find out what Q is because we can substitute it here. This is the first differences. We know the first term of the first difference. They told us in the beginning that the first difference's first term is 7. So this is what we can substitute here. We know that term 1 in this pattern is equal to 7. So we'll substitute it here. We'll say T1, so in place of P, we're substituting 1, is 2 times 1 plus Q. And then in place of T1, we say 7 equals 2 plus Q. And so if you transpose the 2, it's 7 minus 2. So Q is equal to 5. And so therefore, The formula is TP equals 2P plus 5, and that is our answer. Question 3.4 says, which two consecutive terms in the quadratic number pattern have a first difference of 157? Okay, they're giving us a first difference. So at the end of the day, they just want to find out in the quadratic pattern which two terms, okay, have a first difference of 157. So we know the first difference here. Okay, we already have the formula for the first difference, so we can use that here. Here's the formula. It is this. So in place of the term value TP, we're going to substitute 157 to find out which term in the first difference is this. So which term in the first difference gives us 157? That is 157 equals 2P plus 5. And then if you take 5 over, transpose it, you're going to have 157 minus 5, which is 152. So we're saying 2P equals 152. And if you divide both hand sides by 2, we get 50 and 25 and 1. 25 and 1 is 26. And then that is going to be 76. So 76. So this means this is term 76 in the first difference, that is equal to 157. What does that mean about the quadratic pattern? Which two terms here would this be? If it is term 76 in the first differences, then it's going to be between term 76 and term 77. Here's a brief explanation of that. You see, if you have the values of term 1 and term 2 in the quadratic pattern, right? Those, if you subtract them, they give you term 1 in the first differences, okay? So the term that you subtract by will have the same term number as that first difference, okay? So there we go. That's how we know it's between term 76 and term 77. Okay, so this is between term 76 and term 77 of the quadratic pattern. And that is it for question 3.